question 28. Question 28 is actually testing students on the topic of acids and bases. However, when you read the question further, you realize that this is actually testing students whether they can interpret the data that is given to them. Okay, so let's take a look at the question. The dissociation constant for a base indicates the extent to which it dissociates into ions in water. Now, I know we have a very big word, dissociation constant. It is a relatively new term for some of you. It may send some students into confusion. Okay, so don't panic. Continue reading the question and pick out information that is necessary or that is relevant to tackle this question. Okay, so the second sentence starts with the higher the dissociation constant, the greater the extent of dissociation of the base. And the conclusion that helps students answer the question is that a stronger base will have a higher Kb value. Okay, so then you are provided a table with the chemical formula of the compounds with its corresponding molecular mass and dissociation constant. So based on the data given, based on the data above, which statement is correct? So let's take a look at option 1. All the compounds turn universal indicator from green to violet. Okay, when you have universal indicator, right? To know the color of universal indicator in a solution, we need to know the pH. So are we given information on the pH here? We are not. Okay, so this statement, it is inconclusive because insufficient information given. Insufficient information given or no information given about pH of compound. Hence, you cannot conclude anything. Is it really violet? Okay, we don't know because we don't know the pH. Insufficient information is given to the students. Okay, so let's take a look at option B. The higher the molecular mass, the stronger is the base. The sentence or the option is implying that when molecular mass increase, the Kb will also increase. Is that really the case here? So let's take a look. Let's compare compounds A and B because Mr increase from compound A to compound B, right? And then we look at the dissociation constant, you realize that the Kb actually decreases. Okay, sorry, Mr increase, however, Kb decrease. This means that compound B, although it has a higher molecular mass, it is a weaker base. Hence, statement B is out. Okay, because B having a higher molecular mass, it is a weaker base. So option B is invalid. Can? Okay, so now let's move on to option C. Replacing a hydrogen atom with a chlorine atom makes the base weaker. So you need to choose which compounds to compare, and that is actually compounds B and D. Okay, compounds B and D. Why? Because you must see, one of the hydrogen atom here in compound B, it is replaced by one chlorine atom in compound D. Okay, so this is the two compounds that we should compare and look at the effect of Kb. Okay, the effect on Kb. And now the dissociation constant of compound D, okay, the one with the chlorine atom, it is higher. Kb increase, meaning compound D is a stronger base. So when we replace hydrogen atom with a chlorine atom, this makes the base stronger. Hence, statement C or option C is eliminated. Okay, so now we are down to the last statement. There are more hydroxide ions in a solution of compound A than that in a solution of compound C of the same concentration. So you are given the two compounds to compare with A and C, right? Okay, A and C. So you just have to look at the dissociation constant. The Kb of compound C, it is Kb of C is lower than Kb of A. Correct? So this tells you that C is a weaker base. Okay, based on the last statement here, stronger base, higher Kb value. So lower Kb value means weaker base. So C is a weaker base than A. And this implies that if it is a weak base, C has a lower concentration of hydroxide ions than A when we are comparing the same concentration. So there are more hydroxide ions in a solution of compound A than that in a solution of compound C of the same concentration. This option is actually true. And that is why your answer for this question is D. Okay?